Hello. Today we're going to be talking about section 8.2.1. How does the area change? Now, just from reading the title of this section, you can tell that this will be about area. However, more specifically, we're going to be talking about how the area changes between two similar shapes. So in order to do this section, you have to remember about similarity, okay? So to remind you, when we're talking about similarity, similarity means that two shapes have the same zoom factor, okay? And in order to remind you about zoom factor, I'll give you one quick example. So say, for example, we had two triangles, okay? And if you knew that this was 3, this was 9, this was 4, and this was 12, and this was 2, and this was 6, if we wanted to know for sure, are these two triangles similar, we would have to find the zoom factor. And the way we do that is by looking at their corresponding sides. So what I mean by corresponding sides is you look at the same side on each of the triangles. So in this case, we would make a ratio between 9 and 3, okay, like this. 9 divided by 3 equals 3. Likewise, 6 and 2 would make a ratio. So we would have 6 divided by 2 equals 3. And lastly, we would have 12 divided by 4 equals 3. Now these ratios, these are the zoom factors, okay? If the zoom factors for all the sides of the shapes are exactly the same, we know the two shapes are similar. So in this case, because we know that all three sides have a zoom factor of 3, these triangles are similar. They are indeed similar, okay? If all the zoom factors are the same, the shapes are similar. Okay, so that is how we found similarity before, okay? Now, I want to add on one other piece of information. Zoom factor is how we refer to those ratios, the corresponding side ratios, okay? Another name for zoom factor is linear scale factor, okay? Linear scale factor, okay? It's important for you to recognize this because your book may use linear scale factor instead of zoom factor, and you might be confused. They are exactly the same. Zoom factor is linear scale factor, okay? They are equal. Okay. I want to give you one practice problem to make sure that you understand similarity before we move on, okay? So I want to ask you, if you have two shapes, say for example, this and this, and I told you these dimensions can you find or can you figure out whether these two shapes are similar? So what I'd like you to do now, pause the video right now, solve whether these are similar or not, figure out whether these are similar. Once you figured it out, unpause the video and continue. Also, if you can't figure it out, that's okay, but review the first part of this video and try again, okay? So, once again, look at these two shapes, figure out if they're similar. Pause the video now. Okay, so if you're continuing on, it means you've solved this problem or you hit a roadblock, okay? Yes, these are similar shapes, okay? And if you couldn't figure this out, it would be a good idea for you to come and talk to me about it. I'll work with you one-on-one, okay? So, yes, these are similar shapes. Yes, they are similar. Why are they similar? Because when we find the ratios of the sides, if we find the linear scale factor, we find this. 12 divided by 2 equals 6, and 36 divided by 6 equals 6. And the other two sides are exactly the same, so you can see that they are all 6. So our linear scale factor is 6, okay? Our linear scale factor is 6. Also, one other piece of information, okay? Linear scale factor, zoom factor, these things can be denoted as R, okay? So zoom factor and linear scale factor can be thought of as just R, okay? So in this case, if you were finding the linear scale factor and I asked you, what is the zoom factor? What is the linear scale factor? What is the ratio of the sides? You could just write R equals 6. Okay? Alright. Now, that was a review of similar shapes. The new piece that we're adding today is area. Okay? So, let's talk about that. If we're talking about area of two similar shapes, okay? The very first step is to figure out if the shapes are similar or not, okay? So the first step here, if we have two triangles, 1, 2, 2, 4, okay? If these are similar, okay, and I will tell you, this is 2, and this is 4, and this is 2, and this is 4, okay? Now, let's take a look at the height and the base of these triangles, okay? If we take 2 divided by 1, we get 2. If we take 4 divided by 2, we get 2, okay? And as you can see, every other side is 4 divided by 2, so you can tell that all the sides have the same linear scale factor, okay? Thus, the shapes are similar, okay? Now, if we want to know that the two shapes have maybe a relationship in terms of their area, we have to figure out what the area is first. So let's take a look at their area. The area of a triangle is 1/2 base times height equals the area. So in this case, it would be 1/2 times the base, which is 1, times the height, which is 2, equals the area. This ultimately results in an area of 1. Now, for the other triangle, we have 1/2 base times height equals area. 1/2, the base is 2, the height is 4, the area is 4, okay? Now, if we look at this carefully, okay, you can see that the area has increased by 4 times, okay? By 4 times, okay? So even though our zoom factor, linear scale factor is 2, the area increased by 4. So, what can we learn from this? If we know what the zoom factor is, R, okay? If we know that R is the zoom factor, okay? If we know that R is the zoom factor, and we wanted to know how much the area changes from the smaller shape to the bigger shape, okay? We can say that it is R squared, okay? How many times bigger the area gets? Now remember, this is how many times bigger the area gets, okay? So in our case, the area was 1, okay? Our zoom factor was 2. Our zoom factor was 2, but the amount that the area gets bigger by, gets increased by, is R squared, okay? If R is 2, then R squared equals 2 squared, which equals 4, okay? Which is what we have. So, what you want to take away from this, if you know what the zoom factor is, okay, that number squared is that number squared is the factor by which the area increases from the smaller to the bigger shape, okay? So it's how many times bigger the area is of the bigger shape than the smaller one, okay? Okay. So just to give you that written out, if we know the linear scale factor R, then the area of the bigger shape is R squared times bigger than the smaller shape. So if we know that R, our zoom factor, is 2, the factor by which the area gets bigger, okay, is R squared, which equals 2 squared, which equals 4, okay? Zoom factor how many times bigger the area gets. Okay? Okay. So, let's give you some practice. Okay? Here are two shapes. I'm going to tell you right away that these are similar shapes, okay? These are similar shapes. Okay, so what I want you to do here is I want you to find the linear scale factor, okay? What is the linear scale factor? And I want you to find how much the area increases by, okay? What factor does the area increase by? What factor does the area increase by? So, this is your first question, and this is your second question, okay? Pause the video now and figure these out, okay? Unpause it once you figured it out, or if you find that you're really stuck, okay? Okay, so for this first problem, okay, the linear scale factor is the zoom factor. So all we have to do is go it's easier if we go bigger. 12 divided by 4 equals 3, and 9 divided by 3 equals 3. And I already told you at the start of this one that they were similar, okay? So the linear scale factor is 3. R equals 3, okay? So the answer to the first one would be R equals 3. If I want to know the factor that the area increases by, okay, it's going to be R squared. So to solve this one, you would go R squared. We know that R is 3, so 3 squared equals 9. So that's the factor that the area increases by. And you can prove it to yourself, okay? Because these are rectangles or squares, you know that length times width is the area, right? Area equals length times width. So in this case, 4 times 3 would be 12. And in this case, 12 times 9 would be 108, okay? So if we know that those are the actual areas, and we know what factor the area increases by, the way we could check this is take the smaller number, 12, multiply it by 9, and we should get 108, which we do, okay? So, once again, linear scale factor, find the zoom factor, okay? Find the zoom factor. In order to find the area, the factor that the area increases by, square the zoom factor that you found, okay? Okay, next problem. So for this next one, I'm going to give you a different shape, okay? This is a regular hexagon, okay? This is a regular hexagon. So here we have one shape, and here we have another, okay? For its dimension, I'll tell you that this is 20 and this is 80, okay? Pause the video here and try to find the linear scale factor and the factor that the area increases by, okay? Linear scale factor and factor that the area increases by, okay? Okay, did you get r equals 4 and r squared equals 16? If you didn't, go and look at the other examples and see if you can figure out where you might have gone wrong, okay? Or, alternatively, come and talk to me during class, after school, lunch, or seminar, okay? All right, here's another problem. If I know that the area of a shape is 1,000 times bigger than the area of a similar shape, then the area of a similar shape what is the linear scale factor? What is the linear scale factor? Once again, pause the video here and try to do this to the best of your ability, okay? Once you feel like you're ready to move on, unpause the video and find the solution, okay? Pause the video now. Okay, so in this video, in this problem, okay, we see that the area of a shape is 1,000 times bigger than the area of a similar shape, okay? So if the area of a shape is 1,000 times bigger, okay, that is telling us what the factor is that the area increases by. It's the factor by which the area increases, okay? So the area increases by a factor of 1,000. If the area increases by a factor of 1,000, that's going to be r squared, okay? The area of a shape is 1,000 times, okay, bigger. That's a good keyword for you, times, okay? The area of a shape is 1,000 times bigger. It means it's getting that many times bigger from the smaller to the bigger shape. So in this case, r squared equals 1,000. What is the linear scale factor? So what we're trying to find here is we're trying to find the zoom factor or find the linear scale factor, okay? We already know the area increasing factor. So what we have to do here is we look at this as an equation. If we start at r squared, okay, we can square root both sides, okay, to get r. And r equals, if you put this into your calculator, about 31.62, okay? This is the linear scale factor. So remember that r is the linear scale factor or the zoom factor, and r squared, in this case, is going to be the factor by which the area increases, okay? All right, let's try one more problem and then we'll call it for today, okay? So, say for example, you had this. There are 2 rooms. One has an area of 4 and the other has an area of 16, okay? If it costs $10,000, to carpet the big room, how much should it cost to carpet the small room? Okay, so once again, pause the video, give it your best shot, and when you're ready, unpause it and move on. Okay, so if you've given this your best shot, this is how you would go about this, okay? If I know that one room has an area of 4, and I know that the other room has an area of 16, okay? That tells me something right there, okay? That tells me that the ratio of the areas, okay? The ratio of the areas, okay, is 16 divided by 4 equals 4, okay? So the area is 4 times bigger, okay, from the smaller room to the bigger room. And if it costs the big room $10,000, okay, if it costs the big room $10,000, the smaller room will cost about 1/4 of that, okay? It will cost 1/4 of that. So if I know that I had to multiply by 4, okay, if I had to multiply by 4 to go this way, in order to go this way, I divide by 4. So I would take $10,000, divide by 4, and that equals $2,500. So it would cost this room $2,500 to carpet, okay? It would cost $2,500 to carpet the small room, okay? All right, so that is today's lesson on area of similar shapes. Remember, zoom factor, linear scale factor, the same thing. Remember the area, okay? The area is the squared amount of the zoom factor. So if you know the zoom factor R, the factor by which the area increases is R squared, okay? All right. Thank you very much.